Hello everyone, this is another pulley problem. So in our figure, block 1 has mass of 480 grams, block 2 has mass of 50 grams, and the pulley is on a frictionless horizontal axle and has a radius of 4.9 centimeters. So when released from rest, block 2, which has mass M2, falls down 77 centimeters in 5.2 seconds. So this is 77 cm in 5.2 seconds without the cord slipping on the pulley. So we have a couple of questions here. Let's first solve letter A. So what is the magnitude of the acceleration of the blocks? So we have here this information. It falls 77 centimeters in 5.2 seconds. So we can actually compute its acceleration. Okay, so given that it has a falling distance and a time wherein it fell down that distance, we can solve for A. So our acceleration here is equal to 2 times 77 cm over t square. So our time on falling down is 5.2 seconds. Squared. So this will give us an acceleration of 0.057 meters per second square. Okay, so this acceleration is actually for both masses. This A, since it is already given that this mass fell down at this amount of distance. Okay, so for letter B, we want to solve the tension T2 here. And for letter C, the tension T1. So letter B and letter C, tension T2 and tension T1. So redrawing the blocks, we have here M1, M2. It is acted upon forces weight 1, weight 2, tension in mass 1, and tension in mass 2. So we would write summation of forces for M1 and M2. So let's write the summation of forces for M1 first. So we have acceleration is in this direction. We know that A. So we have here M1A equals wait, summation of forces equals M1A. So for M1A, these forces would follow T1 minus weight of mass 1. So this is M1G. Okay, so let's write for M2. So we have M2 times A. So M2A follows a summation of forces with M2G minus T2. Okay, so let's take a look at both equations. We are to solve for T1 and T2. We have a mass. We have A also from letter A. We also have G. So we can solve for T1 and T2.